Let's draw a sign diagram of this function here. Okay. Now, you can see the function crosses the x-axis at -2 and 1. Okay. So you can also see the function is written here, so its critical values are -2 and 1. All right, that's where it crosses the x-axis. So to draw a sign diagram, you simply draw a line to represent the x-axis. Okay, and you go, all right, so it crosses at -2. And it crosses at 1. You can see how it lines up here. It doesn't have to put, okay. So, and then all I do is this. I go, okay, how's the function behaving about these critical values? So for instance, if I said, okay, between -2 and 1, this function is below the x-axis, isn't it? It's below the x-axis. Therefore, we put a negative sign there because it's below the x-axis, okay? After x equals 1 here, the function goes to being above the axis. So it's a positive sign here. But less than -2, the function is also above the x-axis. So it goes to a positive sign here. Another way you can tell how the signs go is this. Because this function here is to singular power, so really that's to the power of 1, that's to the power of 1. If you're to odd powers in the function here, then the sign always changes about the critical values. Okay, so if I've got odd powers, if that was cubed or to the power of 5, etc., the signs about the critical values change. So there's the sign diagram there. Okay, should probably put an X there so that it's representing the x-axis. Okay, let's take a look at this one here. Okay, now this is touching at 1. Alright, so if I was to draw a sign diagram, I'd just go, alright, here's my, I'll pretend it's straight. Alright, I'm not very good at drawing, okay. Okay, so it touches at 1. Okay, so the critical value here is 1. Okay, it touches at 1. Now, what I can see here is that less than 1, okay, the function is below the x-axis. And then as I go across 1, okay, and go higher than 1, the function remains below the x-axis, so it's a negative and negative here. Also, I could look at the function this way and go, oh, it's to an even power. So if it's negative here and it's to an even power here, the sign remains the same. Okay, so that's the sign diagram for this graph. The sign does not change about the critical values. Okay, let's take a look at this last one here, y equals 4 and x. You can see that if x was 0, this function would be undefined, wouldn't it? If x was 0, this function would be undefined. So at x equals 0, we have an asymptote, okay? So whilst it doesn't cross the x-axis anywhere, we know that at x equals 0, it's an asymptote. And so I put a little dotted line here to represent an asymptote, okay? And I can see that at values greater than x equals 0, the function is above the x-axis. At values less than x equals 0, the function is below the x-axis. So there's the sign diagram. So I represent an asymptote with a dashed line here as opposed to just single lines here for the critical value. So a dashed line, okay, represents an asymptote.